All right, we're doing 3, 4. 3, 4A. All right, you physics people, where are you at? Velocity.
I wonder how you'll act on the velocity.
Oh, same. I did devotions this morning, and they walked in on my devotions, so I did it. Yeah. Like in the teacher's lounge, I had devotions this morning, and they came in like 5 minutes late, and they sat and they listened to my devotions.
Was it good?
It was okay, I think.
I hope they don't walk into AP Physics. That's gonna be
Or else they're coming back.
Yeah?
Everyone will be fired.
Okay, let's start off with some Let's start off with some info for you, some information. Here we go. 1, 2, 3, 4, 5. I got like 6 pieces of information for you. Okay, so suppose that f of x is going to be the motion of an object. Motion of an object. Oops, I wrote abject. Object. Motion. What's that? No. I should sit in on his class. I don't know enough about physics.
No, but that's okay. Like, he understands it.
Oops, that's gross.
How he, like, presents it to us. Makes everyone freak out.
Motion of an object. All right. Then, when you take the first derivative, you know that you get instantaneous velocity. Do you know that? You don't know what instantaneous velocity is? Okay. Let's talk about it. Instantaneous velocity is like if the motion of something is going from 0 seconds to 5 seconds, right? And I want to know what the exact speed at 2 seconds is. That is instantaneous velocity. Yes. We've done it. Yes, you're right. And this is called V of t. V of t. Now, if V of t is positive, that means you're going forward. If it's negative, you're going backwards. Okay, if you're on a line going back and forth. All right. Then you take the second derivative. And when you take the second derivative, see, what happens is the first derivative is the change in the motion, which is the speed of it. The second derivative is the change of the speed. And the change in speed is acceleration. Acceleration. And we call this v prime of t, right? Because it's the derivative of the velocity. And a lot of times we call it a of t for acceleration. There is a third derivative, but I don't have it here. I don't know why. I think it's jerk. You know, like when you change your acceleration, it makes the car jerk in a jerky motion. Yeah. Yeah, but I don't know why they didn't say it this time, but they didn't. Maybe that comes up later on. All right, now, if I ask you what the speed is, of the object, you might not tell me that it's the velocity. But what you would tell me is that it's the absolute value of the velocity. See, velocity can be negative, but speed is not. Speed's always positive. If you're going backwards in your car, you're not going negative 10 miles per hour. You're going 10 miles per hour backwards, okay? So speed is always positive. All right, and then 2 more things. We have displacement. Displacement is like where you're at, where your position is. Displacement is usually just y2 minus y1. Okay? That's the displacement. And then you also have average velocity. Not to be confused with instantaneous velocity. We've done average velocity already. Average velocity is going to be the change in s over the change in t. So the change in your displacement over the change in time. It's just basically y2 minus y1 over x2 minus x1. Okay? It's just the slope of the secant line. So, for example, in order to ask you to find the average velocity, I need to tell you 2 times. Okay? So if I say, let's say here's an object and this is how it's moving. And I want you to, at t equals 3, tell me the instantaneous velocity. What you would do at t equals 3 is you would find the slope of the tangent. If I ask you to find the average speed from 1 to 3, okay, 1 to 3, what you would do is you would find the slope of the secant line going through those 2 points, here to here. That's average velocity. Average velocity, you have to have 2 different times. Instantaneous velocity is right then, 1 time. Okay? You see the difference? Yeah? I love this stuff. I should go back to college and take a physics class. I think I would enjoy it. I should. What period is it?
Third.
Nope, I teach that
What about
time.
next semester? Oh, what period do we have next semester?
What period is it next semester?
It's
7th? No,
No,
calculus
it's
is
not morning.
7th.
Oh, that sucks.
It does.
All my appointments are gone all
Oh yeah, we have the 7th.
7th.
I can figure out what period.
AP Gov like 6 or 5.
Joel, and you know what? If you're, oh man, are you in sports? If you're in sport, you're gonna, no, that doesn't count. That doesn't count, yeah.
Kevin, last year we had physics.
Okay, here we go. We're gonna talk about motion along a line.
Oh, okay. Yeah.
Motion along a line. Okay, here we go. Number 1.
Physics is 2nd period.
2nd? Oh, I have 4th off next semester. All right, it says a particle moves along a line so that t is greater than or equal to 0, and s of t is equal to t squared minus 4t plus 3. Now, I said this particle is moving along a line, and you're like, wait a minute, that's a parabola. Okay, it's linear because you're on the ground. You're going like this. You're doing like a parabola on the ground. You know what I mean? Like if I walk that way and I come back around, I walk back this way. And S is in meters, and T is in seconds. Meters and seconds. Okay, here we go. I'm going to ask you a plethora of questions, quite a few of them. Letter A. What we're going to do first is we're going to find the displacement during the first 5 seconds. Find the displacement during the first 5 seconds. Okay, you're going to need to know what these things are. Oops, seconds. Okay, so if I ask you for the displacement, then what you're going to do is you're going to do S of 5 minus S of 0. Okay, displacement is the y value. You want to think about it that way. It's how far you're moving, so it's meters. I want to find out how many meters did I travel from 0 to 5 seconds. Then I would need to do S of 5 minus S of 0. So you go ahead and you plug in 5 into this equation. 25 minus 20 plus 3 is 8. Minus 0, 0 squared minus 0 plus 3 is 3. And so the displacement is 5. And you're going to need units for all of these answers. So 5 what? Meters. You're confused already, Jack?
No, I'm saying I'm so good.
Oh, you're good. Oh, okay. Woo. I thought he said confused. You're confused. No.
I heard him say confused.
I thought I said confused. Yeah, we all heard that, Jack. Okay. Now, what we're going to do for part B is we're going to now find the average velocity for the first 5 seconds.
Wait, is that an S or a Y?
That's an S.
And the second one too?
S, yeah. So it's S of 5 and S of 0. All right, now we're going to find the average velocity for the first 5 seconds. So what's the average speed of this thing for the first 0 to 5 seconds? Well, don't forget, average velocity is just basic slope. It's slope that you learned back in Algebra 1 when you first learned slope. So to find the average velocity during the first 5 seconds, you're going to do y2 minus y1 over x2 minus x1. So you're going to do this. S of 5 minus S of 0. I'll make my S's look more like S's. Over 5 minus 0. Okay? And we already found the first one, right? Didn't we? Wait, yeah. It's 5 meters over 5 seconds. And so what is the average velocity? 1 what? Meter per second. That's the average velocity. Okay, so right now we're still like in Algebra 1, and here we go. Here comes calculus to the rescue. Now we're going to find, to the rescue, the instantaneous velocity at t equals 4 seconds. Okay? I don't know if I spelled instantaneous right, but it's okay if I didn't. We're going to find the instantaneous so heinous velocity at t equals 4 seconds. So I want to know how fast this thing's going at exactly. I know the average speed of it, okay, but at 4 seconds, what's the speed? Well, what you're going to do is you're going to take the derivative, okay? So instantaneous velocity is f prime of x, in this case s prime of t, and you get, what's the derivative of this thing? 2t minus 4. Okay, nice shortcut. You love it. Don't have to take the limits anymore. Beautiful. And then we want to find at t equals 4, what is this going to be? So we plug in 4. 2 times 4 minus 4. 8 minus 4, and we get 4. 4 what? 4 meters per second. Perfect. Okay? It's going pretty fast there. Really fast. Let's find the acceleration at t equals 4. Bless you.
You take the derivative again.
Yes. Two C's, right? Yeah. Acceleration at t equals 4. And this doesn't really matter because, watch, when you take the derivative of s prime of t, so we're taking the second derivative, we end up getting what? 2. So it really doesn't matter. And what is acceleration? Do you know the units on acceleration? Yeah, meters per second squared. Okay? And that's for the whole thing. The whole thing at all times is accelerating at 2 meters per second squared. All right, and then let's go with the last question. Letter E. At what value or values of t does the particle change direction? So when does the particle change direction? What time? Okay, so the particle's walking that way, and then all of a sudden it changes directions and it walks the other way. At what time does that happen? Well, let's think about this. If I'm walking this way, and I decided to change my direction, and then I go this way, if you think about that as a parabola, what is the velocity at that point when I decide to change my direction? It's 0, okay? So we want to find out where, not that. We want to find out where velocity, instantaneous velocity equals 0. Everyone today. Or where s prime of t equals 0. These are the same thing. Your drugs are ready. Well, everyone's drugs are ready. How fun. Have a great Thanksgiving. What's that?
Oh, wait, good time of tea.
Yes, so we already know the velocity, instantaneous velocity of this was what? 2t, what was it? 2t minus 4? So we're going to take 2t minus 4 and set it equal to 0 and solve. So add 4, divide by 2. At t equals 2 seconds, the particle turns and goes in the other direction. Okay, you can graph this parametrically if you want to look at it. I never really did it that way though. But yeah, it's going one way and then it changes direction and comes back. Okay.
Did you get S prime T equals 0? I'm confused about this.
Oh, these are the same thing. So s prime of t is the derivative of your function that was given to you, which is the instantaneous velocity. So the first derivative is the velocity. Yep, that's when there's 0. Okay, let's do the last part, part C. Now we're going to do vertical motion. Vertical motion. All right, here we go. This is a good one. Number 2. It says here that a dynamic blast sends a rock into the air with motion. H of t equals 160t minus 16t squared. Okay? So here's the rock. It's sitting on the ground, and some explosion happens, and it sends it flying. Yes? It's an upside-down parabola. All right, and the height is in feet this time. Sorry, we're back in America. And with respect to t, time, which is in seconds. Time's always in seconds, it seems, huh? Things happen very quickly. Okay, here we go. Let's answer these questions. First one. How high will the rock go? How high will it go? This, will it go? This is not necessarily a calculus problem. It's not really a physics problem. This is like an algebra 1 problem. I just did this to find the maximum is the vertex. You can do a bunch of different ways to get there, though. You can graph it on your calculator, find out where the vertex is. You can do negative b over 2a, which is what we learned in algebra 2. Or, in calculus, how high will it go? When it reaches that highest point, what's the velocity there? The velocity is 0 at the highest point. So why don't we just take the derivative and set it equal to 0 and solve? Okay? So h prime of t is going to be 160 minus 32t. Set that equal to 0 and solve. So we will add 32t to the other side. Divide by 32, and t equals, what is it? Ooh, 5 seconds. Okay, so 5 seconds. And then they might, oh, well, that's not how high will it go. That's when it happens. And then to find out the height of it, you need to plug in h of 5. So h of 5 will be 160 times 5 minus 16 times 5 squared. So it happens at 5 seconds. That doesn't tell you how high it goes. And it reaches a height of 400 feet. There we go. Perfect. Okay. Whew. Now, this next one's tough. Okay, so watch out for this one. Here we go. It says, what is the velocity? What is the velocity of the rock at 256 feet above ground? At 256 feet above ground. Okay. Now, let me explain this to you. So basically, here's that rock, right? And it's blasting off, and it looks like this. And we found that this was 5 seconds. And this right here was 400 feet. Okay? So we want to find out what the velocity is when this rock is 256 feet above ground. It actually happens twice. So this is about what? This is probably half, about 200. So right here, we'll say is the line y equals 256. Okay? And there's a time that that happens at, and there's another time that that happens at. Okay? And I want to find the velocity here, the instantaneous velocity. So I want to find the slope of the tangent line at that point and at that point. Okay? And I know that instantaneous velocity comes from the derivative of my function, but I need to first find out what time is happening so I can plug that into my velocity equation. Do you understand? Yeah? Okay, so what we want to do is we want to set this parabola, this 160t minus 16t squared, equal to 256. We need to find out what t is. Now, a lot of your professors, when you get to college, they will not let you use your graphing calculator for this problem. They want you to solve this by hand, which if I were to do this by hand, I would add 16 t squared over, subtract 160. And here's a quadratic to solve, right? Plus 256 equals 0. You can do whatever you want. Quadratic formula, I would use factoring. And you can actually factor out a 16 from this. They make it so nice for you. T squared minus 10t plus 16 equals 0. And then you can factor this. What times what? 16 adds up to negative 10, negative 2, and negative 8. So t would equal 2 and 8 seconds. Now, that's not the answer, though. Okay, this is a hard problem because you have to find that first, and now we want to find the instantaneous velocity at t equals 2 and t equals 8. So let's go ahead and take the derivative. So the velocity equation is the first derivative. We already did that, right? Yeah. 160 minus 32t. That's our velocity equation. And I want to find the velocity at 2 seconds. And you plug in 2. 160 minus 32 times 2. You can do that on your calculator, and you get 96 feet per second. Okay? And then you find the velocity at 8 seconds. And the velocity is negative 96 feet per second. So that would be the instantaneous velocity. It's really cool. I'm going to show you the acceleration in just a minute. The acceleration should kind of make sense to you. So yeah, that's the next part, part C. What is the acceleration? The acceleration is actually constant. What is the acceleration? The acceleration is the derivative of the velocity equation, or you can think of it as the second derivative of our motion equation, which is what? Negative 32. Negative 32 feet per second squared. Now, you physics nerds out there, why is acceleration negative at all times? Do you know?
Because it's falling. It's being dragged down.
Yeah. So as you're going up,
There's going to be gravity.
yes, exactly. So the velocity is positive on the way up, but the gravity is pulling it down, is negative. I didn't mean to write -1. It's a positive times a negative. And on the way down, your velocity is negative, but the gravity, it's going faster on the way down. So acceleration is always negative in this case. That's pretty cool, right? You're slowing down as you're going up, but you're speeding up as you're coming back down. Like you're crashing to Earth. It's going really fast at impact. Ooh. Okay, so let's answer a couple more questions. We're almost done for today. Letter D.
How many more letters?
2. How long is this thing in the air? How long is it in the air? This one's actually an easy question because parabolas are symmetric. We started on the ground, which is nice. Halfway through, we're at 5 seconds, so how long total are you in the air? 10 seconds. Okay, that's pretty easy since if it wasn't on the ground, like it's up here and it goes, you'd have to figure it out. You would figure out what that is, what t is there, by setting it equal to 0 and solving. It's just your x-intercepts. Okay, and you can do that. Like we could do, it's like where's h of t equal to 0? Where's the height 0? That will tell you how long it's been in the air. And you use either quadratic formula or whatever you want to use. Okay, and the last question. How fast is it traveling when it hits the ground? So how fast, what's the speed of it? How fast is it traveling when it hits the ground? Now, for this question, That question is like, whoa, okay, how am I going to find that? You have to remember that the speed of it is its velocity. When it hits the ground, you want to find v of 10, right? So v of t is the velocity, but I want to plug in 10 because that's the time that it hits the ground. So that's the instantaneous time. So that would be 160 minus 32 times 10, which would be negative 160 feet per second. Now if I ask you for the speed of it would be 160 feet per second. You would take out that negative because speed's always positive. It's pretty fast.